So good afternoon, everybody. Welcome to spring. This is the CMOS Ottawa Centre Lunch Hour Seminar Series. There will be one more on the 18th of April. Please check our website for that. Without further ado, I will turn the introduction of our speaker today over to Peter Kimball.
Thanks, Len. 22 participants, that's great. So I was going to read the abstract, but you probably all know what the topic is, and it's on the screen right now in front of you. So I'll skip the abstract, and I'll just read the bio for our speaker, Yann. Yann Boulanger holds a PhD in biology from the Université du Québec at Rimouski. Between 2010 and 2013, he was a postdoctoral fellow under the supervision of Dr. Sylvie Gauthier and Phil Burden at the Laurentian Forestry Centre, where he worked to define homogeneous fire regime zones in Canada. Since then, he has been a researcher in the forest ecology. His research interests include 1, the projection of natural disturbance regimes in Canada, mainly fire and spruce budworm, in relation to climate change. 2, the projection of forest landscapes and wildfire habitats, and 3, the dynamics of spruce budworm dispersal using weather radar. Dr. Boulanger is an associate professor at the Université du Québec à Rimouski, at Laval University, and at the Université du Québec en Abitibi-Témiscamingue. Very appropriate topic as a result of last summer's wildfires and the smoke that we all experienced. Very interesting summer we had last year. So Dr. Boulanger, it's up to you now. Thank you.
Well, thanks, Peter, and thanks everyone for the invitation. I mean, that's I'm very glad to be here to present here the work that we have done so far on the future of wildfires in Canada. So it's not only my work, it's the work of all of our team here at CFS about the projection for climate change, under climate change, and some kind of a summary of the last season of forest fire. So just summary of what are forest fires in Canada. You can see that it's probably one of the most or the most important natural disturbance in the Canadian forest, especially in the boreal forest. Annually, on average, there's about 2 million hectares that are burning each year. Well, between 2 and 2.5 million hectares on average. But of course, that's very, very variable from a year to another. And most of those fires are occurring, I mean, the biggest ones are occurring within the boreal forest, especially within the central part of the country, north of Saskatchewan, Manitoba, Northwest Territories, Northwest Quebec. And large fires, even though they are quite rare, I mean, those fires are above 200 hectares, even though they are quite rare, they are representing the great majority of the annual area burn in Canada. But of course, 2023 was very different, and you already know probably that this was a very exceptional year. You have here a depiction of the annual area burn from 1985 to 2023, and you can see how much 2023 was different from all of the other years. 2023 was special, I mean, extreme in very various ways. It was, of course, an extreme year where fire weather parameters were extreme. Those extremes were spatially extensive. I mean, it was not only one region that was affected, it was the whole country. And it was also temporarily persistent. So from May to late September, early October, conditions were very conducive for fire pretty much everywhere in the countries. And you have here on the right box plot that are actually in these graphs, you have the different fire weather indices that are there, and each dot represent 1 year between 1950 and 2023. And 2023 is actually the red dot. So you can see that the red dot is, I mean, up in the roof. for all of the fire weather indices for across Canada. So 2023 was a record year for all of those indices, and by a wide margin. Early conditions in 2023 were already alarming when we are talking about forest fires or fire weather parameters. There were signs like snowmelt. Snowmelt just occurred very, very quickly all across the country, very early, well, in most part of the countries, especially in Quebec. In Quebec, actually, the May snow water equivalent was the least in the record, well, at least since 1940. The drought code also was already very high in many parts of the country, especially in the prairies, early May, and also in June. The drought just extend from, well, across much of the country, especially also in northwestern Quebec, where I'm used to work. So already a lot of signs that this season would be pretty bad. And it was actually, when we are comparing or analyzing the parameters for all of the fire season. For example, temperature were way above normal for all across the country. Actually, it was the warmest May to October period for much of the country. You can see there in dark red. Precipitation were also at record level, I mean, record low level for many parts of the country, especially in BC, southern Alberta, southern Saskatchewan, part of the Northwest Territories, most of Ontario, well, northern Ontario, and Northwest Quebec. And also the vapor pressure deficit was also at record level for all across the country. So all of these parameters were, I mean, they are pretty closely linked to fire, because if you want to have a fire, you need warm temperature, dry temperature, and also windy conditions, of course. On other maps here that are depicting to which point the season was exceptional, you have here the number of days that where the fire weather indices were above the 95 percentile. So you can see that in some places, especially at the point where BC, Alberta, and the Northwest Territories are close to each other, the number of days where these fire weather indices were exceptional were very, very high. And actually, that's a place where we had a lot of area burn last year. And across the country, I mean, these numbers were pretty high. We also had record number of blocking, atmospheric blocking also, especially in the northern part of the country, and also in eastern part of the country. And one thing also that is very important to mention for the 2023 fire season is that the number of fire itself was not really different from from the average, the mean number of fire all across the country. It was, 2023 was exceptional because those fires, there were a lot of fires that were really huge. You can see in 2023, we had several fires that were above 200,000 hectares. At least 10 were above 350,000 hectares. And we even had almost 2 fires that were above 1 million hectares. So that's really exceptional. You can see the distribution of the size class of 2023 compared to 1986 and 2022. You can see that those big fires were much more prevalent in 2023 relative to the other years. And if we are comparing things for Quebec, for example, regarding the drought conditions, and we are going a little bit further in time, we know that the drought conditions that we experience, especially in the north and the northwestern part of the province, were exceptional. Actually, they were at record level for if we are looking at data between 1900 and 2020. So you can see that the value in 2023 were much higher than any other years in this time period. And we can see that the frequency of those extreme years when we are talking about drought is increasing, especially in the northern part of the province. And also we had, I mean, the smoke and smoke emissions and the carbon emissions also from, they were at record level also. You're already aware that there were a lot of alerts for bad air quality. Smoke reached the whole continent also. So it's very, that was an extreme year for sure in also these kind of things. I will pass this one. So, and what we are going to expect for 2024? Well, you're already aware that the snow cover, well, maybe that's not the case when we're looking through the window today, but the snow cover is already quite depleted all across the country. When we have very small snow cover, it means that it melts very quickly. And then if it melts pretty quickly, it means that the fire season can start much earlier than normal. And that's pretty much what is already occurring in southern Ontario and southern Quebec. For example, the fire season has already begun. And we had our first fire actually in Quebec last week on March 15. And it was the fourth earliest fire that we had on record. So having fires in March in Quebec, that's pretty rare. Actually, there's only 49 occurrences between 1973 and today. So, and we already know that there are already some drought conditions that were already there last year, but they are still there. They went through the winter for for a great part of the country, especially out west. And when we are looking at the North American multimodal ensemble, we know that for the next coming months, temperature will probably be much above normal. So the conditions will still be very conducive for fire. Of course, if there are precipitation, very difficult to say on those very long-term forecasts. But if there are enough precipitation, probably maybe that will compensate for those conditions there, but still we have to be very aware of that. Oh, sorry. So of course the impacts of wildfires are numerous. There are economic impacts, social impacts, ecological impacts, impacts on public health. So the impacts are very, very diverse. And of course, if we are going through evacuation, so on the social side of things, so you have here a map of the evacuations that occurred because of wildfires between 1980 and 2007. But since that time, there were a lot more evacuations that occurred. Actually, you can see the graph on the lower left, and you can see that 2023 was a record year in terms of numbers of evacuee. It was more than, actually, I think these numbers are, yeah, they are through June 29. So when we are looking at the numbers at the end of the season, we're above 200,000 people that were evacuated from 125 different evacuation events. So that's almost, I mean, in 2023, there were almost the same number of evacuees that there were between 1980 and 2007 as a whole. So that's a lot. And we can talk about the Fort McMurray fire, for example, as an example of economic loss. You probably remember this fire, so the Horse River fire that occurred in the beginning of May 2016. It was a very, very large fire, so 600,000 hectares, 90,000 evacuees from Fort McMurray, 2,400 buildings destroyed. And actually, that was the largest insurable loss from a natural disaster in Canada. So almost $10 billion that was lost in these in this sinister disaster. Of course, there are many impacts on the health. For example, people that are that have asthma, pneumonia, cough, for example, they are visiting much more the emergency rooms when there is smoke in the air from wildfires. That was especially the case in Northwest Territories in 2014, where when actually they were in what they call the summer of smoke. There were a lot of increase in ER visits because of those symptoms and because of the of wildfire smoke in the air. Of course, there are other recent examples of consequences of the fire in Canada, and those consequences are getting much worse, I would say, when we're especially looking at what happened last year. So, of course, to better, in order to better understand the, so are you still hearing me? Because I think that my microphone just stopped. Is that okay? Just make me a thumbs up or.
All good.
We hear you.
Oh, okay, cool. Sorry.
We can't see you.
If you want to understand how fire is working, you have to understand what are the variables that are driving fires. Actually, they can be separated in three different categories. You have the ignition part. Of course, ignition can come from human or nature with lightning. And of course, you have to also understand the vegetation, because some forest cover classes are more flammable than others. And of course, you have to understand climate. If we're looking historically to fire in the country across the last 300 years, for example, we know that fires all across the country actually were much more abundant, or there was more area burned within the Little Ice Age, for example, across much of the country. That can be a little bit counterintuitive when we are talking about the climate change impact, for example. But when we are comparing to the 20th century, there was actually a decrease. But why was that? Probably because even though during the Little Ice Age, even though if it was colder, it was actually a little bit drier, so it was a little bit more conducive for fire then. And fire suppression also began in the 20th century, so it had a great impact. There was also a lot of indigenous fires, especially out west, that were brought down for almost to zero within the 20th century. But those trends should change, and actually they are actually changing. I will show you just after. If you want to also understand fire regimes, you have to understand the impact of temperature on fire, especially on fire size. So, of course, if it's warmer, fire can be much bigger. And actually, if we are going back in time and we are analyzing the impact of temperature or June temperature, for example, on fire size, we can see that for each degree Celsius warmer, the fire size is actually tripling. So, of course, if the temperatures during the month of June, for example, are increasing, this will have an impact on the fire size into the future. Because, yeah, temperature are increasing. That's not a big surprise. 2023 was the warmest year on record on the globe by a wide margin, actually. And if we are looking to Canada, of course, temperatures are increasing a lot, way more than on average on Earth. The temperatures are increasing, especially in the northwestern part of the country. They are increasing in any season, and of course within the fire season, so within the spring, summer, and fall. And if we are looking at trends since 1950, for example, in some very important variables for fire, like mean temperature in June or July or August, or anyway, you can see that those temperatures are increasing. Relative humidity is actually decreasing in some part, not everywhere, but in some part. The drought code is also increasing. As I was saying before, the snow water equivalent during the spring is decreasing a lot, especially out west. And it means that fire season, I mean, it melts more quickly. And so the onset of the fire season can be much earlier. And the values for the fire weather index, the max values, so the extreme values, they are also increasing, especially in the boreal forest, actually. If we're looking at all across the world, I mean, these trends are occurring well, almost everywhere. So you can see that for the extreme value of the fire weather index, these values are increasing almost well, especially out west in the northwestern part of the northwestern part of Americas, other parts of the Europe and Asia, southern Africa, also Australia. So there are many variables that are in very upward trends all across the world, and it means that the world is much more flammable than it was before. Especially, it makes the vegetation much drier when we are looking at the dryness or of the vegetation. You can see that there is an increase in this kind of dryness in a lot of places around the world. And in Canada, we can see that this increased dryness is especially important in northwestern Quebec, northern part of the country, within British Columbia, for example. So when it's drier, it means that it's much more flammable. I was talking to you about the earlier onset of the fire season. We can analyze also change in the fire season length. And so this is for between 1979 and 2015. And you can see that for almost everywhere in Canada, especially in the central, northern, and eastern parts, fire season is getting much longer. And we're talking about almost, I mean, the trend is about, in some places, it's about 1 day more per year. So it means that within this time period, some places have a fire season that is about a month longer than it was before. So that's a lot, especially in Quebec. And when we're looking at all of those fire parameters together, it means that we just looked at the weather parameters, but now we can look at the fire regime parameters. And of course, if there are trends in weather parameters, there are also trends in fire parameters themselves. And when we are looking at the annual area burn, for example, all across the country, these area burn are increasing since late 50s. Actually, they are doubling. They have doubled since the late 50s in Canada. So, and we are now at on average at 2.5 million hectares. And these increase occurred almost everywhere when we are talking about annual area burn. But when we are talking about the numbers of fires, well, most of the country haven't seen actually an increase in the number of fires. Actually, some places have seen a decrease, especially in southern Ontario and southern Quebec, probably because prevention, the number of fires from human origin, they are much less numerous. Actually, when we are looking at the numbers of fires, the cause of wildfires, we know that human-caused fires are decreasing in the country, whereas lightning-caused fires are increasing. And one thing also that is very, very interesting is that the largest fire are getting larger. So the 95th percentile of fire size is getting much much bigger. In the late 50s, for example, a large fire was about 20,000 hectare wide, but now it's about 40,000 hectare wide. Also, we had just few examples of the impact of climate change on the fire season. We can look at the 2017-2018 fire season in BC. Actually, I just made this slide in 2018, and I had to change it in 2021 and 2023 because the conditions were still worse than what it was in 2017 and 2018. So in BC at that time, we had very smoky sky. We had record fire season in 2017 with 1.2 million hectare. This record was beaten the year after in 2018 with 1.35 million hectares. And actually in 2023, it was just, I mean, blown up, this record. We had 2.2 million hectares. So, I mean, BC is just having record season after record season since 2017. That's crazy. We can also analyze to which point climate change was involved in those conditions. So, for example, if we are talking about the fire season in 2017 in BC, analysis are showing that actually the conditions that were driving those fire were 90% attributable to climate change, whereas the conditions that drove the Fort McMurray fire, for example, in 2016, they were at least 1.5 to 6 times more likely to occur just because of climate change. This one I will just go through. We can also do the same analysis for Quebec for 2023. I was involved in the analysis that was conducted by the World Weather Attribution Initiative that look at to which extent the weather conditions that were driving the fires in Quebec between the month of June and July were attributable or not to climate change. And actually, they were quite a lot driven by climate change. For example, we analyzed the highest value, average value over a week for the fire weather in this index, and you can see that there's a trend between 1940 and 2023. 2023 actually was the highest value that we observed for this parameter, and when we are analyzing a lot of different models, we arrive to the conclusion. We conclude that actually the conditions that were the weather conditions that occur during that time period were at least twice as likely to occur because of climate change. So it doesn't mean that, of course, those conditions were not occurring before. It means that they are twice as likely to occur in the current climate. And also, we know that these conditions will be twice as likely to occur relative to today in 2050. So it will get worse. That's the conclusion. I'll go through that. So if it's getting worse, it means that there are a lot of consequences on the economy, on the social parts of our society and stuff. So we know that since 1970, for example, the fire suppression costs are increasing. I mean, annually they are the annual cost, they are increasing by 120 millions every decade. And just to give you an example, last year, just for BC, it cost more than, I think it was more than $700 million just for BC for suppressing fire. So that's a lot. We are talking about more than $1 billion for Canada as a whole for the suppression effort last year. So it's still increasing a lot. If we are projecting ourselves into the future, we know that the temperature will increase depending on the different climate scenarios. We are projecting increase in temperature between 1.4 and 4.7 degrees Celsius, depending on the IPCC scenarios, but depending on the policies that we already have to reduce the greenhouse gas emissions, or the commitment that we already have, this could be a little bit less, but still it means that at a global scale, we could see an increase in temperature between 1.8 and 2.7 degrees Celsius, probably by the end of the century. Just here an example for Quebec. So we're just before I was just saying that temperature at the global level could rise between 1.8 and 2.7 degrees Celsius. But of course, if you remember, Canada is warming much faster and much more than the globe as a whole. So it means that temperature, for example, in Quebec will be much warmer by the end of the century. And if we compare with today, under RCP 4.5 scenario, which is middle of the road scenario, we could see an increase of temperature of about 4 degrees Celsius, a little bit more than 4 degrees Celsius. And under RCP 8.5, we could see an increase of temperature of 6 to 7 degrees. So that's a lot. And if we are looking at precipitation, those precipitation are increasing a little bit, but not that much. So it means that this very small increase in precipitation will not be able to compensate for the very important increase in temperature. So it means that by the end of the century, we could be in a much drier landscape. Also, if we are looking at the change in the so what was it? Okay, so that's the fire season. So the length of the fire season, we can see that so the beginning of the fire season, sorry. If it's getting warmer, it means that spring also will get warmer. So the fire season itself will begin much earlier, and we're talking about in some places more than 40 to 75 days earlier than what it is actually right now. If the conditions are also more conducive for fires, it means that we will have more of what we call the spread days. The spread days are the days where the fire is conducive for fire spread. So it means that the fire weather index is very high. And those number of spread days will increase a lot, especially under RCP 8.5, especially in the central and northern part of the country, and especially by the end of the century. And if the fire season will get longer, if the weather conditions are getting worse for fire, it means that the annual area burn will also increase a lot in the country. And these are the projection under different climate scenarios and different time period compared to today. And you can see that in a lot of places, we could see huge increase in annual area burn. So we are talking about 2- or 4-fold increase in some places compared to the last 30 years, for example. So that's a lot, and it means that the consequences also will be very harsh for a lot of different sector of the society. And we can look actually what will be the impact on what we call the wildland-human interface. So the wildland-human interface is actually the wildland-urban interface, wildland-industrial interface, and the wildland infrastructure interface. And you have those interfaces that are in colored on the map here. And on the maps, you can see to what kind of fire return interval those interfaces will be exposed. And you can see by the end of the century, so this is under RCP 8.5. You can see that there's a lot of areas that will be exposed to fire cycle or fire return interval that will be less than 50 years. 50 years for a fire return interval, that's very, very, very short. There are very few places in Canada that are currently experiencing that kind of active exposure from fire. So society will be exposed. Population also will be exposed to much more fire. And it means that if we are looking at how many people will be affected by those very, very short fire intervals. So there will be much more. There will be much more under RCP 8.5, and there will be much more by the end of the century. And one thing that is very important to say also is that First Nation they are already much more exposed to fire, and they will be even more exposed by the end of the century because of climate change. So this is really important to understand. So, for example, under RCP 8.5, the proportion of the people that will be exposed to fire return interval that are less than 100 years would increase from 5 to 14% for non-First Nation communities, but for First Nations on reserves, this exposure will increase from 10 to 35%. So that's a lot. And I mean, the fire return interval of 100 years, that's still short when we are talking about forest fires within Canada, within the boreal forest. So are there any solutions for that? So the first solution to when we are talking about, for example, wildland fire or wildland urban interface or a human interface is, of course, to know the risk. Currently, there are very, very few maps or products that are standardized and that are illustrating what is the exposure or even the risk for population, for infrastructures, and so on. These kind of analysis are very, very important. There is some work underway for that. There's also some specific area that were analyzed in the past. For example, we participate to an analysis that was conducted within the northwestern part of the province here in Quebec, where we have a lot of hydroelectric facilities there. And we were asked by Hydro-Quebec to look at what could be the exposure to fire for those infrastructure in the future. So that's very important to know. And actually, those maps are working pretty well, because you have on the lower right a map of burn probability that was created in 2021, and you have superimposed where the fires of 2023 occurred. And those fires, on average, they occur in area that we first identified as much more at risk than other area. There are still some areas that are at very, very high risk that have not burned yet, but I said yet because they could burn very, very quickly because the conditions there are very conducive for fire spread. We can also make it so that the forest, the communities, and the infrastructures are more resistant to wildfires. And one way to do that is to make the landscape around those communities or infrastructure with fuels. I mean, when I'm talking about fuels, I'm talking about vegetation that are less flammable. For example, some tree species are less flammable than others, like deciduous species, for example. When they have their leaves, they are less flammable than coniferous trees, for example. Of course, that's not the panacea. I mean, the deciduous trees can also burn sometimes, especially in the spring when they don't have leaves yet. But still, that's something that could be done. Of course, there's also cultural burning by indigenous people. These are conducted actually in time of year when the fire cannot spread quickly. So like in the fall, in November, for example, and when those fires are conducted, the fuels are reduced, and so for the next year it means that there is less stuff to burn if fire could occur, so that the fire could be much less severe, much less intense also. Of course, you're maybe aware of what we call Fire Smart Canada. So Fire Smart is a program that is now led by the CFC, where communities, industries, or they could join the Fire Smart program. And this program is actually it's like a framework to make your community or infrastructure less exposed or less at risk to fire. Like they will propose to reduce the fuel around your house, around the buildings, change the fuels around the communities, having building codes also that are different, that make it so that the buildings are less flammable themselves. So this is a way to do it. And there are a lot of communities out west that are certified as Fire Smart. Many First Nation communities also, especially in BC, for example. And one thing also that can be done is to increase the suppression mitigation capacity of the different provinces and territories. For example, in Quebec, we know that in 2023, the capacity of the air tanker just capped out at about 3,000 hours. So we were not able to use them more than that. Probably also because the fire were so intense that even air tanker were not successful to rout down the fire. So we have also an aging fleet. There's also a scarcity of qualified pilots. So of course that's something that we have to think about. Of course, it's not the panacea. Also, this is part of the different tools that we can use to reduce the risk around the communities or the infrastructures or the value at risk. But we cannot think that we'll be able to bring down every fire within the intensive protection zones, for example, because we have seen from last year, for example, the SOPFEU, which is the agency, fire management agency in Quebec, they are able to manage about 30 to 40 fire on a daily basis. But actually, for 45 days in a row, there were more than 40 fires in activity that were active. In some days, it was above 150 fires. So you cannot have people or air tanker everywhere, of course. We are also calling for a unified risk management approach. So we just talked about fire risk here, or fire exposure, but there are also many other threats or hazards, natural hazards in Canada, and those hazards are accumulating. Actually, they can also interact between each other. So we have to consider the whole natural hazards. Like, for example, producing a zonation of those threats, hazards for the country or for the provinces, and take into account the cascading effects of for example, wildfires or any other natural hazards on the territory. So you're already probably aware of that, but we have, just to finish here, to conclude, we have a lot of tools available to follow the fire activity in all across the country. You can visit our website at the Canadian Wildland Fire Information System. There's also another website that was created by our colleagues at UQAM, which is called the ESCAR Center, where you can also see the activity of current fire, but also the historical trends in weather parameters that are related to the fire weather indices. You have also where are the atmospheric blocking and stuff. So that's very important for fire. So here it is. It was my talk. I'm ready.
Thank you. Thank you very much, Dr. Boulanger. That was great. I'm going to look through the chat for questions. I know that I sent Dr. Boulanger a few questions of my own, but I'm going to start with a couple of questions that came to the chat. two of which are similar. One was, do you have an estimate of what percentage of fires overwintered and maybe start points for the 2024 season? And another question, which is very similar. We had a talk last year at the Arctic Circle about zombie fires in the north. Are they increasing? Can they be controlled?
Well, I'm not very knowledgeable about those zombie fires, and we have very little information about those fires. From what I can say, we have colleagues in Netherlands that are, for example, studying those kind of zombie fires in Alaska. So they have studied that, and they conclude that about 15% of the annual area burn in Alaska was caused by those zombie fires. So fire that occurred in the previous year that went through winter and then rebirth the year after. And about 15% of the annual area burn is caused by those fires. We know that there's about 150 of those fires that are called zombie fire currently in Canada. So from the 2023 fire season, of course, those fires are more probable if they first occur within a season that was very, very dry, because it means that the soil or the organic matter is dry at a very at great depth. So it means that if this organic matter can burn very, very deep, so it can pass winter or go through winter more easily. And then if the conditions are still conducive, so if it's still dry in the spring or summer, those fire can reborn. So but it's very difficult to have data about
that. Thank you. I've been asked if you could turn on your video, Jan. Easier.
Yeah, I just tried it. Actually, my webcam is not working. I just received a error message during my presentation, so I'm very sorry about that.
No worries, no worries. We can certainly hear you very well, so that's fine. Yeah. Okay, I'm going to turn to. I actually sent Jan 4 questions of my own, but I'm going to boil 3 of them down into one.
Okay.
Basically, they all concern the causation of the forest fires, basically from human caused or lightning caused. And question number 1A was: has there been any attempt to sort through last year's forest fires, separate human caused ones from the other lightning caused ones? For example, I think Nova Scotia was likely human caused, and we've heard that there were people. One guy was arrested in Quebec for having deliberately set a number of fires. And then also, lightning statistics from 2002 show a flat trend. So there's no increase in lightning over the last 22 years. Have you considered this in your studies? And 3, any thoughts about 2020, record low forest fire season? Perhaps the result of COVID lockdown, suggesting maybe a larger human causation influence than we would like to believe. So they all kind of relate to, lightning, people causing fires. How do you consider that in your statistics, et cetera?
Yeah, that's the great question. It's variable from a year to another, but if we're talking about the number of fires, that's about 50-50. So 50% of the fires are caused by human and 50% by lightning, for example, if we're talking about the number of fires. But if we are talking about the area burned by each fire cause, it's about 91 on average. It's 90% of the area burn that is caused by lightning caused fire, and the rest is human caused fire. And last year, for example, 41% of the ignitions were human caused. So the rest was lightning caused fire, and lightning were responsible of 93% of the area burn. Of course, we are sometimes talking about arson and stuff like that, but these are very, very low numbers. That number of fire, and even lower numbers for area burn. And what is interesting also about the 2023 fire is that we had we had a very low number of lightning last year, but those lightning were very, very, very efficient. They occur sparsely, but when they occurred, the conditions were pretty dry. Well, the conditions were very dry actually and very warm. So it means that once there was a lightning causing ignition, the fire could spread very, very quickly. And those conditions were suitable for the growth of very large fire. Regarding 2020 season, I don't have any ideas why I didn't analyze the stuff. I think it was pretty wet this in 2020, if I recall right, or the conditions. You know, to have a lot of or very wide area burn, very large area burn. It means that we must have winning conditions for a lot of parameters. So we have to have warm temperature. We have to have ignitions, of course. So even though if it's warm and dry, if we don't have any ignition, I mean, there's no fire. So I mean, it's difficult to have all of these conditions together to have a very active fire year, but those conditions were there last year.
Okay, great. Thank you for that. Another one of my questions regarding climate change. We hear climate change will cause increased humidity and flooding, but also increased drought and fires. Are these not mutually exclusive?
Mm-hmm. That's a good question. Of course, when we are talking about precipitation, we know that those precipitation can occur at a very short time period, and they could be very intense, delivering a lot of accumulation of water. But at the same time, you can have blocking that will be much more prevalent, and those atmospheric blocking will cause very warm temperature locally, regionally, or at the synoptic scale, actually. And those warm conditions, very dry conditions, will be very, very important for fires and for wildfire spread, ignitions and stuff. So it really depends where, and it really depends when actually those conditions are occurring. But if those extremes are occurring more often, it means that there is one part of the extreme, if it's dry, so the fire will occur very easily.
Okay, thank you. Another question from John Stone. Could you say something about CO2 emissions from forest fires?
Yeah, that's a good question. We know that for Canada, for example, well, last year was a very exceptional year for wildfire emissions. But on average, Canada, since I would say the beginning of the 2000, is now a source of carbon because of natural disturbances. So it can be because of very active fire year, or it can be also because of insect outbreaks. But since 2000, Canada is a source of carbon or about some years are the exceptions, but we are a source. And if we are projecting ourselves into the future, because natural disturbances will be more common, it can be insect outbreaks, but of course, wildfires, the probability of for Canada to be a sink for CO2 or for carbon is getting much lower each year, each decade. So yes, because of the increased activity of fire, we are much more a source than a sink.
Thank you again, Dr. Boulanger. I think we're out of time. It's 12:57, and we have just a couple minutes left. Len, I want to turn it back over to you for closing remarks.
Thanks, Peter. I would just like to take this opportunity to thank Jan Boulanger for an excellent talk, certainly timely, and we all appreciate it. And this will be now a recorded session on the CMOS National YouTube channel. Jan, thank you very much. I will remind you all about the 18th of April final seminar in this series. Check it out on our Ottawa CMOS website. It's basically teaching climate change from a professor at the Carleton University, Joanna Dean. So thanks very much, everybody, and have a good spring.
Thanks a lot for the invitation.
You're welcome.
Have a good one.